sketching derivatives from functions and functions from derivatives. So if you're given a graph, you can sketch a possible derivative graph without knowing what the function is and vice versa. So let's have a look at a graph. So we're going to have a graph looking like this that we're going to call f of x. And we don't really know anything about the graph at first glance, but let's take note of a few things. So we want to sketch the derivative function of this. And in order to do that, remember, the derivative of a function is the gradient of the tangent at every point. So just to make this a little more clear, we might write that instead of y, we're going to have our derivative. Now, derivative is the gradient of the tangent. So what's happening to the gradient of the tangent along this curve? Well, all the tangents over here, if we draw tangents in, let's draw them in. So some tangents over here, they're all going to have positive gradients. Right at the top, if we draw a tangent in, that's going to have a gradient of 0. Tangents all along here will have negative gradient. A tangent right at the bottom here will have a 0 gradient. And tangents all along here will have positive gradients. So when we go to sketch our derivative function, we actually want to look at the values of the gradients of the tangent. So we know they're positive here, 0 here, negative here, 0 here, and positive here. So I like starting by looking at where zeros are. So let's line them up. And if a value of 0 for our gradient function is going to be on the x-axis, because all along our y-axis, they're the values of the gradient. So if we're in line with 0 here, that's where we're going to have a 0 value for the gradient of the tangent. If we have positive values for the gradient of the tangent, we need to be above the x-axis. And if we have negative values for our gradient, we need to be below the x-axis. So if we're going to be above the x-axis on this side, we need to be above. So we're going to draw a line in that goes above. Then we need to be below in between these 2 points, and then back to being above after here. So if we put all that together, we're going to get something like that. Where if we can see, positive values above, 0 on the x-axis, negative values all below the x-axis, 0 on the x-axis, and positive values above the x-axis. All right, let's try going the other way. So this time, let's look at the same graph, but this time we start off with the derivative function. And we want to graph the original function. So we need to think with reverse logic here. So this time we have the derivative function. So that means we want to check just the values that we have. So values below the x-axis are negative, values on the x-axis are 0, values above the x-axis are positive, values on the x-axis are 0, values below are negative, values on are 0, and values above are positive. And these represent the gradient of the tangent of our original graph, which we're going to draw down here. So this is going to be our original graph. So when we go to draw it, we need to be doing negative gradients over here a zero gradient in line here, positive gradients in between here and here, a zero gradient here, negative gradient here, zero gradient here, and positive gradient here. So let's line up our zeros. And that's where we're going to have stationary points. That's where we're going to have zero gradients. So we're going to be flat there. So if we've got a negative gradient coming into a flat gradient going out to a positive gradient, we can think about we're going to have a negative gradient going to a zero gradient going to a positive gradient. Then we're going to a zero gradient, negative gradient, zero gradient, and positive gradient. So that's our basic shape of the graph. So when we draw it nice and smooth, we're going to get something like that. And it doesn't really matter where you draw it along the y-axis, because this is just a possible function for our derivative function. There's actually infinite answers here because we could have drawn it anywhere along the y-axis. So just bear in mind that this part here is not needed for your final answer. Just use that as a guide.